In this video, we will demonstrate how to solder leads to either our analog or quadrature encoder breakout. For these tasks, you will need the following items: soldering iron, tweezers, wire strippers, solder, 1-inch long piece of heat shrink tubing, 1.5 inch long to 1 inch by 1 inch diameter, and some wire cutters. First thing we need to do is cut and strip 4 leads to solder to the breakout board. I did this off camera, so we're ready to go to the next step, soldering the leads to the breakout board. When soldering, it's important to make sure that you have a good, clean tip, the right temperature. I'm using 750 degrees for this. This is lead-free solder. And you want to make sure that you get a good liquid puddle on the tip of the iron like this here. That'll help transfer the heat to the wire or the thing you're trying to solder more effectively. So I'm going to go through here and solder these leads, and you'll notice that I'm just using just enough solder to tin the lead. Now if you look, there's a little ball on the tip of this. I'm going to go ahead and clean that off because we want to make sure that we don't have too much solder. And I'm also going to go ahead and I'm going to re-tin this guy here. Get a little bit of puddle on the tip of that iron, and that'll help the heat transfer to the wire. And there you go. Soldering wires 101. So soldering surface mount pads is not complicated at all. In fact, I prefer surface mount pads to through-hole pads in some cases. With a little bit of knowledge, you can be proficient at soldering surface mount pads. I'm going to show you a quick little demo here on how I do it with our breakout boards. So the first thing I like to do is make sure that we have a good clean soldering iron. It's important that the tip of the iron be very clean and free from oxidation and any kind of debris that may interfere with the soldering process. So cleanliness is important. The other thing you want to make sure is using a good quality solder. I'm using a lead-free solder here. Kester, or a really good brand. Indium also makes lead-free solder that I recommend as well. But if you're using leaded solder, that's fine. This will just be easier for you. The temperature I'm using for this process is 750 degrees Fahrenheit. So the first thing you're going to want to do is make sure your tip is wet. You want to get a nice, good solder puddle on that tip. And you want to let that puddle conduct the heat to the pad you're trying to solder. I like a lot of solder on my pads just because it helps with when you join the wire to the board, it helps transfer the heat. You get a nice big puddle of solder, and then you just touch the wire to it, and the wire bonds right to it. As soon as you remove the heat, you're good to go. That's the process I like to follow. So I'm just going to go ahead and continue tinning these here, and I'm using a relatively about a 45 degree tip angle. Oh, see, I got to get a little wet there. See, there we go. Yeah, when you get the tip wet, it just flows a lot easier. Get a little solder on the tip here. Get a little bead down there, a little flux. There we go. Good flow. Now I found that when you hold the tip at a flatter angle, you get a lot better heat transfer. Obviously you have more surface area in contact with the piece you're trying to solder. But you also run the risk of touching this connector here, and I'm trying to avoid that because I don't want to melt it. But you can do it with different angles and different pressures. The key is to just make sure you have the tip wet. So now that pads have been tinned, we're going to go ahead and put our leads on. So we're going to start with this red lead here that we tinned earlier, and we're just going to either hold the wire with a pair of tweezers, or you can hold it with your fingers. Just, don't burn your fingers. You want to make sure that the strip length is appropriate. You don't want this going into the connector and touching these pads. And you also want to try to make sure you see this little edge of insulation here. You want to try to make sure that's right on the edge of the board. You don't want that underneath because it'll melt and it'll kind of cantilever the connection a little bit, which, can create stress on the solder joint. If you do get it underneath, it's not the end of the world. Just try to avoid it. So what I like to do here, again, got to keep the tip clean. Got a little bit of oxidation on there since the last solder job here. So I'm going to hold the tip here. I'm going to make this liquidous, and then I'm just going to insert this guy on, and then we're done. That's it. Now, if you're a perfectionist, you can try to recenter that. You can always reheat the pad and move it over. But that's an acceptable solder joint. It's good, reliable, not cold, not too hot, just right. So let's go along here and solder the rest of these. So this guy can be a little tricky because he's on a ground plane. So if you look at this pad here, he's connected to a bunch of copper in the, surrounding it. There's a big polygon on the bottom side of this board that's grounded, and so this is what you call a mask defined pad. And what that simply means is the solder mask defines the area of the pad. So why is that important? Well, it's important because you tend to need a little bit more heat and a little more dwell time, or time in contact with the solder pad, in order to get good heat transfer and good flow. You want to make sure you have good heat transfer and good flow, otherwise you'll end up with things like a cold solder joint or an overheated pad or an overheated solder joint, and those tend to fail if not addressed. So it can be a problem, so we want to avoid it. So let's take a look here. We're going to tin this pad here, this ground pad, the same way we tin the other ones. We're going to heat it up with some liquidous solder, and then we're going to just let it kind of pool up like that with surface tension to give us a nice bead. Now here's the thing, you can put a lot of solder on this pad, right? And it'll just keep, the dome will just keep getting bigger and bigger and bigger until eventually, it won't be able to hold any more solder. Now, that's okay, because not having enough solder is a bigger problem than having too much. And it's kind of hard to get too much with these because of the way the pads are designed. So we're going to clean the tip off again, and we're going to go ahead and solder this guy. Oops, so you got a little balling there. Let's get that off. Whoop. There we go. So what do you do with your breakout after you've soldered the wires to it? How do we keep these wires from breaking off, becoming stressed, pulled, bent? How do we protect this board from debris, from maybe some conductive debris that may fall on it, moisture, what have you? Well, the answer is I like to use a little bit of heat shrink. Now this heat shrink has some glue inside of it, so it's got a little adhesive, but you can use any size any type of heat shrink. This, I believe, is 1-inch heat shrink, and doesn't have to have the adhesive in it, but I like to center it, and then got a little ceramic tile here just so we don't melt our table for this demo, but I'm going to use a heat gun. I'm going to go ahead and hit that with some heat, being careful not to melt our ribbon cable. We just want to get the heat shrink. So get that, go ahead, flip it over, get the back side. And then, because this has an adhesive in it, I didn't quite get this centered, but because it has an adhesive in it, it kind of conformally coats the entire board. In the end, it's a little hot, so I'm kind of being careful here, but conformally coats the inside of this and seals the wire ends. So this is a very inexpensive and quick way to seal up your breakout adapter. You can trim this and make it look pretty. You can put whatever wire in here you want. This is just some 24 gauge wire that we pulled from some multi-conductor cable here. But this is how we do it. This is how we recommend you do it. This will protect it from any kind of foreign debris, any kind of metal shards that may get in there, and it also helps strain relief the wires a little bit and provide some anti-kink, which, you know, one of the limitations of the surface mount pads is if you or any wire to board connection that requires solder is if you flex these too much, they'll break off. It can stress the joint, it can cause the solder to crack, it can cause the pad to delaminate. This strain relief here, this heat shrink, acts as a strain relief to help eliminate some of those concerns. So that's what we do, this is what we recommend, and thanks for watching.